Hello everyone, and thanks for watching Edupedia World videos. This is the third video on the topic of vectors, and in this we'll cover the topic of vector multiplication, which is multiplying of two vectors together. Let's say you have the vector A and the vector B. We know how to add these two vectors, we know how to subtract these two vectors. Now we learn how to multiply these two vectors. There can be two types of multiplication: the dot product, which is often written as A dot B, and the cross product, which is often written as A cross B. So there are two types of multiplication, and when it comes to division, it does not exist. There is no real way of dividing one vector by another vector. So division as it exists does not happen for vectors. You can obviously divide a vector by a scalar, like if you divide a vector by 5, that is simply multiplying it by the scalar 1 by 5. But you cannot have A vector divided by B vector. Right. So these are the two types of products we'll study in this video. The first one is also often called the scalar product because the result it gives is a scalar. If A and B are two vectors, A dot B will be a scalar. That means to completely specify A dot B, you only need to specify the magnitude of A dot B. You don't need to specify the direction because it doesn't have any. On the other hand, the cross product is a vector product. Meaning if A and B are both vectors, A cross B will also be a vector, which means to uniquely determine A cross B, not only do we need the magnitude of A cross B, but we also need the direction. Let's start with dot product and then we'll move on to cross product. And once again, we'll follow the same pattern we followed in the previous video. First, we'll do it in terms of magnitude and direction. Meaning if you give me the magnitude direction of two vectors, I'll give you the magnitude of their dot product, and then we'll do it in terms of components. Meaning if you give me the x and y components of two vectors, I will give you the dot product of the two vectors. By the way, I want to mention one small thing. Everything we are doing right now is for two dimensions x and y, but the generalization to x, y and z is quite simple enough. And we'll study that in a lot of detail in a later video when we start studying three-dimensional geometry. That's why I haven't covered that now. But the simple cases like the magnitude will not be root of x square plus y square, it will be root x square plus y square plus z square. And things like that are quite natural enough. So anyway, let's see magnitude and direction. If we have two vectors, the first vector is A and the other vector is B. And now we don't need the direction of the two vectors. All that we need is the angle between them. Let's say that is theta. Theta is the angle between the two vectors. We've already seen in the previous video that the angle between two vectors is defined as either the angle between their tails or their heads, but do not take the angle to be the angle between one tail and one head. You'll get the wrong answer by a factor of 180 degrees. So, given the magnitude and direction of two vectors, that means the magnitudes are A, B and the angle between them is theta. A dot B is simply defined as mod A into mod B into cos theta. Now A dot B, like I said, is a scalar. So this is the magnitude of A dot B. We don't need to worry about the direction because there is none. So let's say you have one vector of magnitude 5 units, another vector of magnitude 10 units, and the angle between them is 30 degrees. Then what will be the dot product of these two vectors? 5 into 10 into cos 30, which is equal to 50 cos 30 or 25 root 3. Right. Now, if theta is 90 degrees, then cos theta will be 0, which means the dot product of two perpendicular vectors is 0. Right. If theta is between 0 and 90, cos theta is positive, which means the dot product is positive, since these two are always positive. And if theta is between 90 and 180, for example, if this is one vector and this is the other vector where the angle between them is 150 degrees, cos theta will be negative, which means their dot product will be negative. The angle between two vectors is always between 0 and 180 degrees. Right. So this is quite simple enough. This is one of the few cases in which solving in terms of the magnitude and direction is somewhat simpler than in terms of the components. You have the simple formula mod A into mod B into cos theta. And remember this case 5 and 10 with an angle of 30 degrees, because we'll do this again in terms of components. This is basically the case we've studied before. 5 at an angle of 30 and 10 at an angle of 60, which means the angle between them is 30. And the dot product is 25 root 3. Right. So this was in terms of the magnitude direction. Let's see what it is in terms of the components. So I'll just simply start with these two vectors itself. The first vector 5 making an angle 30, the second vector 10 making an angle 60 with the x-axis. In the previous video, we calculated the sum of these two vectors by two different ways. Now we've calculated the dot product, which was 25 root 3 with the first way. Now we'll calculate the dot product in the second way. So first, our goal is to write A and B in terms of components. We know what that is. A is equal to 5 cos 30 I cap, or 5 root 3 by 2 I cap, plus 5 sin 30 j cap, 5 by 2 j cap. B is equal to 10 cos 60 I cap, or 5 I cap, plus 10 sin 60 j cap, or 5 root 3 j cap. Now what is A dot B? Well, the good thing about working in components is you can just take these components to be individual terms and apply the standard rules of product. So this will basically be 5 root 3 by 2 I cap plus 5 by 2 j cap dot product with 5 I cap plus 5 root 3 j cap. Now I can expand this. This will give me 4 terms. The first term will be 25 root 3 by 2 I cap dot I cap. Right? This vector dot this vector, the magnitudes multiply I cap dot I cap. Plus, then we will have 25 by 2 j dot I. Plus, we will have 20 plus with this term. So, we will have 75 by 2 I dot j. And finally, the fourth term will be this into this 25 root 3 by 2. Right, so we have these four terms involving I dot I, j dot j, I dot j, and j dot I. So let's calculate the values of these four using magnitude direction. And these four values you should remember. I dot I will simply be mod I into the angle between these two, which is 0. So cos of 0. And the magnitude of I is 1 because it's a unit vector. So basically I dot I is equal to 1. Similarly, j dot j is equal to 1. Now what is I dot j? Well, I is in the x direction and j is in the y direction. The angle between them is 90 degrees. So cos theta will be 0, which means j dot I will be 0 and I dot j will be 0. J dot j will be 1 and I dot I will be 1. So the final answer is 25 root 3 by 2 plus 25 root 3 by 2, or 25 root 3. Right. So basically what you do is you write them into components, follow the standard rules of dot product, and then you follow these rules, which is I dot I and j dot j are 1, whereas I dot j and j dot I are 0. This basically corresponds to multiplying the I components together, multiplying the j components together, and then adding them up. Right. So this completes dot product. Now we'll move on to cross product. Once again, we'll start with magnitude and direction. So which means that if we have two vectors A and B, we are given both their magnitude and direction, which means we know the angle theta, which is the angle between A and B. Then A cross B. Now remember, A cross B is actually a vector, not a scalar. It's a vector product, also called the vector product. So it will have both a magnitude and direction. It will in fact be a vector, right? So we will first define the magnitude and then the direction, right? So the magnitude of A cross B is defined as mod A into mod B into sine theta. For dot product, it was mod A mod B cos theta. Here it's mod A mod B sine theta, right? And so if the angle between two vectors is 0 or 180, their cross product will be 0. The cross product will be maximum if the angle between them is 90, because sine 90 is 1. The direction is a little bit more complicated, and it is given by what is called right hand rule. right? So let's look at what the right hand rule is, and now we'll have to introduce a third direction as well. So whenever we talked about I and j, correspondingly there is also k. K is the unit vector in the z direction, right? I, j and k is it corresponds to x, y and z. So the right hand rule basically states that a cross b, the direction is perpendicular to both a and b. So let's say this is my first vector a and this is my second vector b. So we need a vector which is perpendicular to these two vectors. Now there are only two possible directions which are perpendicular to both these two vectors, and those directions are perpendicular to the plane of your screen, which we've seen this before, referred to as going inside the plane or coming out of the plane. So the direction of a cross b, which is perpendicular to both a and b, can either be going into the plane, that means going away from you, going away from the viewer, or coming out of the plane, which is coming towards the viewer. But it will not be in the plane of the screen, right? It will be perpendicular to the plane of the screen in the third direction. Now which one of the two is it? That is determined by the right hand rule, in which you place your right hand along the first vector and curl your fingers along the second vector. I suggest you do this with me because it's important that you learn this, and the direction of your thumb gives you the direction of the cross product. So basically, if you put your hand such that your fingers are around A and you curl them towards B in this direction, your thumb will point towards you, right? There's no way to do it unless your thumb points towards you. So in this case, it will be towards the viewer. Now, if we had B cross A, right, this is another difference between dot and cross product. Dot product A dot B is equal to B dot A, but for cross product A cross B is not equal to B cross A. In fact, it's the negative of B cross A, because even though the magnitude is the same, if you curl your right hand fingers around B and try to move them towards A in this direction, you'll see that you'll have to basically put your hand something like this. Something like this. Your hand will point inside the plane away from the viewer and your fingers will curl in this direction towards B. So if you have A cross B, you place your fingers of your right hand, and it has to be the right hand, towards the first vector, and you curl your fingers towards the direction of the second vector. And whatever the direction of your thumb is, that tells you the direction of the cross product. Now that does sound somewhat complicated, but what you should remember is all of that we do only to determine which one of the two it is. We already know that it's going to be perpendicular to the plane of A cross B. Which one of the two is it is generally determined by the cross product, right? So that is how you do it in terms of magnitude direction. What about in terms of components? So let's just do the magnitude and direction once for our special case 5 and 10. So our first vector is 5 at an angle of 30, second vector is 10 at an angle of 60. So if we want A cross B, this is A, then our fingers point towards 5 and curl towards 10. So the answer will be coming towards the viewer. Right, sorry, this is going away from the viewer. This is towards the viewer. It's coming towards the viewer. This is X and this is Y. But also, what is the magnitude? 5 into 10 into sine 30, which is 25. So for these two vectors A and B, A cross B is a vector of magnitude 25 pointing in this direction, coming towards the viewer. Right. Now, before we try to solve the same thing in terms of components, we need to figure out what our Z direction is. If you have this as X and this as Y, then the Z direction, the positive Z direction, could be towards the viewer, away from the viewer. The convention generally is chosen that it will be towards the viewer. The convention generally basically is chosen such that if you take your fingers around X and curl them towards Y for the right hand, your thumb should point towards the Z. So if X is in this direction, Y is in the upward direction, then Z cannot be away from the viewer, it has to be towards the viewer. Right, that is the convention we choose. For a unique value of X and Y, you can have two directions of Z. You need to choose one always every time, otherwise you will get different answers as you choose different ones. So we always choose it such that if you curl your fingers around X, if you put your fingers in the direction of X, curl them in the direction of Y, your thumb will point in the direction of Z. right? And this is useful when you're doing in terms of components to get the cross product of the basic unit vectors. So we'll just take our two vectors. The first one was 5 and 30, so it was 5 root 3 by 2 I cap plus 5 by 2 j cap. The other was 10 at 60, so 10 cos 60, that is 5 I cap plus 5 root 3 j cap. This is A, this is B. We need to get A cross B. And once again, we can just cross multiply them directly. What we get is 5 root 3 by 2 I plus 5 by 2 j crossed with 5I plus 5 root 3j, which gives me 25 root 3 by 2 I cross I plus 25 by 2 j cross I plus 25 root 3 by 2 j cross j plus we want I cross j. So plus 75 by 2, 5 root 3 into 5 root 3 I cross j. Right, so these are the four terms we get. Now we need to find out, just like in the case of dot product, what is I cross I, j cross j, I cross j, and j cross I. Now I cross I is 0 and j cross j is 0 because the angle between I and I is 0 and sine theta is 0. The formula for magnitude was mod A mod B sine theta. Now I cross j and j cross I will obviously be opposite to each other. One is in the z direction, the other is in the minus z direction. How do we resolve this ambiguity? That's what we talked about earlier. I cross j will always be k, because if this is x, this is y, x cross y has to be z. So j cross I will be minus k, the negative z direction, which means this is 0, this is 0, I cross j is k, j cross I is minus k, 75 by 2 minus 25 by 2 gives me 50 by 2 or 25k, which means a cross b in this case is equal to 25k. Now this is also important. The magnitude is 25, but the direction is the positive z direction. If we took b cross a, then it would be a vector of magnitude 25, but the direction would be the negative k direction or the negative z direction. So I'll just give one brief recap of everything we've done so far. We've done everything in vectors in two forms. One way to do it is in terms of magnitude and direction. The other is in terms of components. The first thing we did in the first video was learn how to convert between the two. Given the magnitude and direction of any vector, we know how to calculate the components. Given the components, we know how to do magnitude and direction. Then we did the addition of two vectors, both in the magnitude and direction and the component form. Then we did scalar multiplication. And once again, we did it for both of them, meaning given the magnitude and direction of two vectors, we know what the, magnitude and direction of one vector and a scalar, we know what the magnitude and direction of their multiplication is. Given the components of a vector and a scalar, we know what the components of their multiplication is. Then we did dot product, and again we did it in both forms. And finally we did cross product, and again we did it in both forms. So in a question, let's say in a question you are given one vector in the magnitude and direction form and the other vector in the component form, and let's say you need to find out the direction of their cross product. So you have one way. You can convert the second vector into magnitude direction form, and you can use the cross product formula, which gives you the magnitude and direction of cross product. Or you could take a slightly longer way. You could convert the first into the component form, then you have two vectors in the component form. You get the cross product of the two vectors in the components form. Now you have the components of a particular vector, then you can convert it into magnitude and direction. And it will just come with a little bit of practice, the knowledge, which way would be most convenient for you. Right now, I would suggest that you try all the possible ways and get the same answer from all of them. This completes the unit of vectors. In the next video, we start three-dimensional geometry. Thank you.